So now we're going to move on to solving algebraically and not using a graph. We could use a graph, but 21 is pretty large to put on a piece of graph paper, right? So we need to have a method that's more efficient than putting it on a graph. So the algebraic steps are very similar to the algebraic steps that you would take when solving absolute value equations. So the first step is to isolate the absolute value expression. So we need to get the absolute value of 4 minus x by itself. So I'm going to start by subtracting 15 from both sides. So I'm going to have the absolute value of 4 minus x is greater than 6. All right, so just like what we talked about earlier, we want to be more than 6 units away from 0. So that means that 4 minus x has to be greater than 6, or 4 minus x has to be less than negative 6. All right, and then we have to solve. So we're solving for x. We subtract 4. So we get x, the negative x is greater than 2. Now we have to divide both sides by negative 1. Okay, and I'll actually write this down, because it's important to remember when you divide or multiply by a negative with inequalities, it flips this sign. So we're going to get x is less than negative 2. And on this one, same step, subtract 4. So that'd be negative 10. And we get x is greater than 10. Okay, dividing by negative 1 flips that sign. Negative 10 divided by negative 1 is positive 10. So the question is, does it stay an or is it now an and? Well, let's put this on a number line to see. So x has to be less than negative 2. And the other one is x has to be greater than 10. So should we use an or and an and? Well, it should be an or, because if you put and, that's saying that x has to be less than negative 2 and at the same time has to be greater than 10. That is impossible. So this is still an or. All right, next one, just going through the steps here, we would add 10. So we have the absolute value of x plus 4 is less than or equal to 8. So that means x plus 4, that quantity has to be less than 8 units away from 0. And at the same time, x plus 4 has to be greater than or equal to negative 8. And just to repeat myself, that is because the absolute value is distance from 0. So this quantity, this distance from 0, has to be less than or equal to 8 units away. So now, if we solve for x, we would get x is less than or equal to 4. And on the second one, we'd get x is greater than or equal to negative 12. So again, if we put that on a number line, we'd get closed dots this time, because it can be equal to that. And then shading in between those two values. All right, so try example 3 and example 4 on your own. Pause the video, and then when you come back, the answers will be here for these two. All right, so I wrote this note. We'll talk about this in a second. I just want you to focus on the solutions. So here's the first solution to example 3. And then we have the solution to example 4. Now, I will mention something. A common misconception that students have is, shouldn't I have flipped the sign here because I'm dividing a negative? No, it's not that I'm dividing a negative. You only flip the sign when you divide by a negative. So there's a key word there. It's what you're dividing by. All right? So the sign wouldn't flip in this case. So you should have seen a pattern by now in dealing with these problems. And the pattern is this. If you start with a greater than or equal to, that is going to go with the word or in between your solutions. And the graph, if we graph our solutions, is going to be disjoint, meaning it's going to be on the outside of your two solutions. Okay? If you start with the less than or equal to, you're going to use the word and in between your solutions, and the answers, if you graph them, are going to look like this. It's going to be between the two numbers. All right, now on to some word problems. So a machine at a lumber mill cuts boards that are 3.25 meters long. It is acceptable for the length to differ from this value by at most 0.02 meters. Write and solve an absolute value inequality to find the range of acceptable lengths. So the first thing that I think you guys are going to pick up on, because it's one of the last things you said, is range. And you're going to think, do I need to draw a graph and find the range of that? No. What it's asking for is, what are the acceptable lengths of the boards if they're supposed to be 3.25, if there's a tolerance of 0.02. So this is like your distance. This is why absolute value is used, because this is like your acceptable distance away from 3.25. So run through a situation in your head. This will help you write this inequality. If you take a board, okay, and let's say it's 3.28 meters long, okay, is it going to fall within this tolerance of 0.02 meters? What would you do to figure that out? Well, if it were me, I'd take 3.28, I'd subtract 3.25, and I'd say, well, that's 0.03. This says it can be at most 0.02, so that I have to throw that board out. It's too long. It doesn't fall within this tolerance. So you see what I did there is I took my board length, and now our board length is unknown at this point. That's our unknown. Okay, so I'm going to say X is my unknown. I'm going to take that unknown board length, and I'm going to subtract the length that the board should be. Okay? And I'm going to put that in absolute value, because that value has to be less than or equal to 0.02. Okay, the word at most goes with the inequality less than or equal to. All right, so then we solve. So we get x minus 3.25 has to be less than 0.02. We're starting with less than, so this is going to be an and. X minus 3.25 has to be greater than or equal to negative 0.02. All right, so now we add 3.25, and we get x is less than or equal to 3.27. So 3.27 is the longest board that can be cut and be within the tolerance. And x has to be greater than, if I add 3.25, I get 3.23. So here's the largest board size, here's the smallest board size. You could also write it like this. 3.23 has to be less than or equal to x, has to be less than or equal to 3.27. All right, and that's how you solve that problem. Last example, a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.01. So again, here's your tolerance. Write and solve an absolute value inequality to find the range of acceptable weights. Okay, so just like the previous one, x is going to be whatever box of cereal we're weighing. We're going to subtract off the weight that it's supposed to be. Okay, and it's acceptable for the weight to vary as much as. Okay, so it can be 0.1 ounce or lower. So again, this is going to be less than or equal to 0.1. So then solving this, we'd have x minus 13.8 is less than or equal to 0.1, and x minus 13.8 has to be greater than or equal to 0.1. Okay, in solving, you would have x has to be less than or equal to 13.9, and x has to be greater than, this should be negative here, sorry for that. If you add 13.8 to negative 0.1, you get 13.7. Okay, now I should have mentioned on the previous problem, whenever you're answering a word problem, don't just answer it like you're answering an equation. Write in words what this means. Always with word problems. Okay, so this means that the range, going back to this previous problem, the range of acceptable board lengths is from 3.23, and we're using meters in this problem, 3.23 meters to 3.27 meters. To answer this last one, we would have the box of cereal must weigh between 13.7 ounces and 13.9 ounces. All right, and that's absolute value inequalities.